Our project covers a library terminal application that handles a database with books, stationery, music, and computers for users to interact with in a seamless manner. With this application, a user can add or edit books and other items in the database, check them out for a period, and return them all within the application in a user-friendly format. Our database follows second normal form for database normalization. Each table is designed to be atomic, and all information within is dependent on the primary key of each table to ensure minimal data redundancy and bloating. The structure of the application is simple. In the main menu, we have access to several submenus dedicated to handling different areas of the database with their select features, such as the Book submenu, which allows you to add, edit, and remove books, as well as features to check them out and return them. This functionality is extended to the other areas, such as music, stationery, which offers purchasing features, and the computers, which a user can book in advance. We have 5 dedicated tables, each designed to be separate and self-contained within their scope. This includes the user accounts table, book repository, computer list, music, and stationery with all their relevant information and parameters. The main app seamlessly integrates all of these and allows full manipulation of the data within using predefined methods and classes to handle any and all actions a user could want when interacting with this database. Our team prioritized equal workflow and collaboration in all areas of the project. We divided the tasks into equal chunks, which allowed everyone to have maximum involvement in both the database design and population, building the Java client with its respective connecting classes to manipulate these tables, along with the main app, which we all worked on together to build and add the functionality for our classes. We had regularly scheduled weekly meetings in person to discuss our workflow and relevant tasks, as well as collaborating and assisting each other when we ran into unexpected problems. In addition to the in-person meetings, we also communicated daily on WhatsApp and Teams to ensure an open line of communication at all times, so everyone was up to date on the development of our project. As you can see, we utilized Project Manager to track and document our workflow over the course of the project. We kept a running list of all of our tasks, separated and broken into smaller milestones to keep track of our progress to ensure we didn't fall behind on major features. Each task was assigned to a person in the group that they were responsible for implementing, along with expected durations and deadlines to ensure a regular and consistent workflow over the course of the project. For our research, we utilized the resources and experience given to us by our object-oriented programming module. The examples given to us by our lecturer, as well as previous assignments, were all instrumental in aiding us towards the completion of the project. We used a number of online resources, including W3Schools and JavaTpoint.com, to help us where our knowledge of particular syntax and some classes and dependencies were lacking. We also collaborated with other teams at times when they encountered similar issues, sharing our knowledge and offering tips and strategies to overcome roadblocks with both coding and interpersonal group coordination with the development of the project. We implemented a comprehensive suite of JUnit tests to rigorously test our application and classes to ensure all of our features were working correctly and didn't break unexpectedly when adding new features over the course of the project's development. This includes individual tests of all methods in our connecting classes by using temporary test data, as well as suite tests to ensure full functionality of the class across all methods to ensure no unexpected bugs. The goal of our project was to build a library terminal application to allow a user to interface with a number of different tables of information within the database. The main application provides a full list of all the features a user could need in order to enjoy a seamless library experience with all the functionality at their fingertips, without the need for dedicated staff and a comprehensive self-service terminal.
So, on the right, we have MySQL Workbench, which is displaying the table book in the Magnolia library database. This stores a number of books that we can manipulate and edit with the help of our dedicated Java client. And on the left here, we have the class dbbooks, which handles all relevant methods responsible for manipulating the books table on the database. It implements an interface called dbmethods, which standardizes many of the repeated methods for database manipulation across the other classes. As you can see, it has a number of methods to perform a wide range of features that are all populated by user-prompted information in the main application. It can add a new book to the table, edit its information, delete a specified book, check out the book if a user account rents it, return the book once they're finished reading, and perform a number of search-related queries to retrieve and display relevant book lists as the user wishes. This class is also complemented by a number of JUnit suite tests that test these methods in a simulated environment. It adds a test book to the database, checks it out with the test user, returns it, and then deletes it from the database all in one go. I will demonstrate the tests and then run through adding a new book through the main application. So first, we will attempt to add a test item to the database, or a test book. And as you can see at the bottom, it has passed the test, and if we refresh the books table, we can see that it has added a test name book to the database. Now we can go through checking it out, which will update its rented status along with assigning it to a test user of number 5. Returning the book will then reset its status, and then at the end we can delete the item, which then removes it from the database. Now that I have given a brief overview of how the books class works, we will now attempt to add a new book and check it out in our main application. So we will navigate through to the books submenu of our main app and add a new book to the database. I will go with Crusade by Elizabeth Laird. This was published in 2007. And as we can see, the book has been added. So if we refresh our columns here, we can see that Crusade has been added to the database with an ID number of 30. So now we will check it out with our current signed in user of ID number 5. So we will check out the book, and I will input the ID number of 30. And we can see that it has updated. So if we refresh the books table, we can see that it is now assigned as rented to the user account of number 5.